Hello, good morning. Hello, good morning. Right. So, today we have to discuss with one more important application of the low range transformation. Already I told you the low range transformations, low range transformation applications we are discussing now. The first application we discussed in the previous class, that is the length contraction, and the second application we have to discuss about the simultaneity. The third application is today we are discussing, that is about the time dilation. How this is very beautiful phenomena in special theory of relativity. Einstein introduced a great beautiful phenomena. Once you have to see what is a time dilation, right. So, time dilation is very important application of the low range transformation. Once you have to see, let a frame S dash be moving along the x axis. Suppose if you have to take the two frames of reference, this is the S frame of reference along the x axis is there, right. S frame of reference along the x axis. One more frame of reference is there, that is the S dash frame. So, this one also along the x axis, these two frames are parallel frames. So, let S dash be moving along the x axis with velocity. How much velocity is moving? With velocity v is moving relative to the S. Once again you have to see, let a S dash be moving along the x axis with velocity v relative to the S frame. Now, if a clock being at rest in the S dash frame, suppose if you have to take one clock, so which one you have to take? One clock you have to take. So, this clock is at rest. Where it is there? This clock is at rest now, right, in S dash frame. Suppose if a clock being at rest in the frame S dash, if a clock being at rest in the S dash frame measures the time, so this measures the time in S dash frame, it is rest, measures the time t1 dash and t2 dash, measures the time t1 dash t2 dash of two events occurring at a fixed position. At particular position is, what is that position? X dash position. Position is the same at fixed position x dash. This is very important. At fixed position x dash. In this frame, then the interval of the time between these two events, so therefore the interval of the time in this frame, the interval of the time between these 2 points, this between these two events, so what is that interval of time? T2 dash minus T1 dash, T2 dash minus T1 dash. So, this time we call it as a, which time it is? Proper time. Which time it is? This is very important. This time we call it as a proper time. What is the proper time? The time interval. So, the time interval between the two events in a fixed frame, so we call it as a, which one it is? Proper time. And the time interval according to the observer in the frame S frame, so there is a time here is there, so that time, so dt is equal to t2 minus t1, so in S frame. So, this time we call it as a improper time, improper. So, otherwise you have to take delta tau, you have to, that is the tau dash, I have to take delta time. This time we call it as a improper time. Clear? Once again you have to see, this is very important. What is the proper time? What is the improper time? to understand the proper time and improper time, that is very important. So, once you have to see, let a frame S dash be moving along the x axis, let a frame S dash be moving along the x axis with velocity v relative to s. If a clock being at rest in the S dash frame, clock is being rest in the S dash frame, measures the time T1 dash and T2 dash of two events occurring at a fixed position x dash in this frame, then the interval of time between these events delta T dash is equal to T2 dash minus T1 dash. This time we call it as a proper time, and time interval according to the observer in S frame is that time we call it as a improper time. So, that time delta tau is equal to which one we have to take, T2 minus T1. From the low range transformations, now we have to observe from the low range transformations, from the low range transformations we know, from the low range transformations, from the low range transformations, which one we have to write, T dash is equal to gamma into T minus Vx by c square. This is the low range transformation corresponding to the time coordinate. So, T dash is equal to gamma into T minus Vx by c square. So, T is equal to gamma into T dash plus Vx dash by c square. Which one we have to write? This is the inverse low range transformation in terms of the time coordinate. This one is a low range transformation. This one is the inverse low range transformation. This one we call it as a low range transformation. This one is a inverse low range transformation. From this, we have to apply this to the two cases. What is our case? Once you have to see, T1 is equal to gamma into T1 dash plus Vx dash is divided by c square. Vx dash is divided by c square. This is the equation number 1 for the first event. T2 is equal to gamma into T2 dash plus Vx dash is divided by c square. This is the equation number 2 for the corresponding second event. Now you have to take, so T2 minus T1 is equal to gamma into T2 dash minus T1 dash. T2 dash minus T1 dash. This equation you have to take equation number 3. Which one you have to take? Equation number 3. Therefore, what we have to write once you have to see, T2 minus T1 is equal to gamma into T2 dash minus T1 dash, correct? T2 dash minus T1 dash. T2 minus T1 we have to take it as a delta tau, gamma into T2 dash minus T1 dash is equal to delta tau dash. So, delta tau is equal to gamma into delta tau dash, right? Gamma is a low range factor. What is that gamma? Gamma is one factor. That factor we call it as a low range factor. Gamma is equal to 1 by square root of 1 minus v square by c square. Gamma is equal to 1 by square root of 1 minus v square by c square. Therefore, what we have to write, delta tau is equal to delta tau dash is divided by square root of 1 minus v square by c square. delta tau dash is divided by square root of 1 minus v square by c square. So this one, this time we call it as a, which time it is? Improper time. Improper time. So this time we call it as, which time it is? Proper time. Which time it is? Proper time. Improper time and proper time is there. So based on this, what we have to write? 1 by square root of 1 minus v square by c square is greater than 1. Suppose if you have to take, what we have to write? Delta tau is equal to, improper time is equal to delta tau dash is divided by square root of 1 minus v square by c square. So therefore we have to take, since 1 by square root of 1 minus v square by c square is greater than 1. 1 by square root of 1 minus v square by c square is greater than 1. Therefore what we have to write? Delta tau is greater than the delta tau dash. So delta tau is greater than the delta tau dash means improper time is greater than the proper time. Improper time is greater than the proper time, right? This is very, very important. That's why this phenomena we call it as a time dilation. Time dilation means time lengthened. Time is lengthened. So time is lengthened. So lengthened, time is lengthened. Time is lengthened means the process are slow, go to slow down, right? The process are go to slow down. So what we have to conclude from this, once we have to see, thus the time interval measured in the frame S is larger than the time interval measured in the frame S is larger than the time interval in the frame S dash. This is very, very important. The time interval measured in the S is larger than the time interval measured in the S dash frame, in which the two events are occurring at a certain point x dash. This is called time dilation. This phenomena we call it as time dilation. This one we also call it as lengthening of the time interval. What is this? This time dilation is nothing but lengthening of the time interval. Time dilation is nothing but what it is? Lengthening of the time interval. Therefore, this means to stationary observer the moving clock will appear to go slow. Stationary observer, the moving clock will appear to go slow. Moving clock will appear to go slow. Therefore, two events appear to take a longer time when they occur in a body in motion relative to the observer than when the body is at rest related to the observer. Therefore, two events appear to take a longer time. When it is a longer time, when they occur in a body in the motion. Body in the relative to the observer. Motion in the relative to the observer. Then when a body is rest related to the observer, improper time is greater than the proper time. That is the meaning. So therefore, what we have to explain to this, if delta tau is the decay of life of mesons, if delta tau is the decay of life of the mesons of the radioactive matter as measured in the S dash frame, in which the particle is at rest. So the delta t is equal to delta tau by square root of 1 minus v square by c square is the decay of life observed in a frame S in which the particles are moving with velocity v. The particles are moving with velocity v. So, we have to apply this time dilation principle in elementary particles also. Not only this, one more conclusion also you have to see. What is that conclusion once you have to take? If v is less than c, if v is less than c, what we have to write? Delta tau is equal to delta tau dash is divided by square root of 1 minus v square by c square. Delta tau is equal to, so delta tau dash is divided by square root of 1 minus v square by c square. If v is less than c, this one is very small, that's why in the denominator part you have to neglect. Denominator part you have to neglect. So, therefore, what will happen? Delta tau dash only it will come. So, if it is v is less than c, what we have to write? Improper time is equal to proper time. Improper time is equal to proper time. That is very important concept. If v is suppose are equal to c, velocity is equal to c, what will happen once you have to see? Delta tau is equal to delta tau dash is divided by is suppose are equal to square root of 1 minus 1. 1 minus 1 is equal to 0. Something by 0 is equal to infinite. Something by 0 is equal to infinite means improper time. Which time it is? This time we call it as a improper time. Improper time towards to infinite means what is this? This is not possible, this is impossible means it is a imaginary concept it will come. So, therefore, the process of aging will stop together. So, that is that meaning, the process of aging will stop together. This is the meaning of that. Not only this, once again you have to see the time interval between any two events which has been measured relative to a frame in which the same two events take place at a certain point is minimum. The time interval between any two events which has been measured relative to a frame in which the same two events take place at a certain point is minimum. Thus, time interval we call it as a proper time interval. Which interval? Proper time interval. It is represented by delta t dash, delta tau dash is given by delta tau dash is equal to delta t into 1 minus square root of 1 minus v square by c square. This delta tau dash is which time it is? Proper time. Which time it is? Proper time is equal to delta t is which time it is? Improper time. So, this time we call it as a improper time is into square root of 1 minus v square by c square it will come. So, the stationary observers, the moving clock will appears to go slow. Time dilation is equivalent to the slowing down of time dilation is equivalent to the slowing down of moving clocks. This is very important. What is the meaning of the time dilation? Time dilation is equivalent to the slowing down of moving clocks. So, hence you have to take a growth, aging, pulse rate, heartbeats. These are the examples of the slowing down in a fast moving frame. So, if you have to take a fast moving frame, growth, aging, pulse rate, heartbeat. So, these are the examples are slowing down in a fast moving frame. So what is the application of the time dilation, where we are using this time dilation? This time dilation effect has been verified experimentally by observation of elementary particles, by atomic clocks accurate to nanoseconds carried abroad aboard jet planes. In the jet planes, so we have to use a atomic clock. Which clocks we are using? Atomic clocks we are using to get the accurate time. Which time it is? To get the accurate time we are using. So this one we have to use. This is very important one. Once you have to see, this is the story about so what is this time dilation phenomena. Once again you have to see what is the introduction of the time dilation phenomena. Time dilation, once you have to see, let a frame S dash be moving along x axis with velocity v relative to s. Now if a clock being at rest in the frame S dash measures the time t1 dash and t2 dash of two events occurring at a fixed position x dash in this frame, then the interval of time between these events is delta t tau dash is equal to t2 dash minus t1 dash. This time we call it as a proper time, and time interval according to the observer in the frame S is that time we call it as a improper time. So therefore delta tau is equal to t2 minus t1 we have to consider. So what is the relation between the, by using a Lorentz transformation we have to get the relation between the time dilation relation. Delta tau is greater than the delta tau dash. Improper time is greater than the proper time. Clear? So that is the thing. Once you have to see the conclusions of the time dilation conclusions, once you have to see v is less than c, then it is equivalent to delta tau is equal to delta tau dash. V is suppose are equal to c, then the improper time is going to infinite. So it is impossible, it is not possible, it is come as a imaginary quantity. Therefore the process of aging will stop together. So the process of aging will not stop together. That is the concept we have to develop this, right? So what is the application of the time dilation application? What is the time dilation application? Once you have to see what that. So verification of time dilation, muon or mu minus meson elementary particles, muon or mu minus meson elementary particles we have to take. What is that muon or mu minus meson? Muon or mu minus meson. Mesons are elementary particles. In elementary particles, I told one lecture in nuclear and particle physics lecture. There I gave the how many elementary particles are there, I gave in our YouTube channel. Once you have to go and see in that lecture, otherwise I have to teach while I am starting the particle physics. I have to teach mu minus meson is a elementary particle. Mu minus meson is the, which one it is? That is a elementary particle. In that elementary particle mu minus meson, we have to observe one observation. What is that observation? Once you have to see a verification of time dilation phenomena we have to observe. First, in the universe there is a cosmic rays are there. In the universe, which one is there? Cosmic rays are there. In the universe you have to take, so these are the cosmic rays. In the universe cosmic rays are there. Cosmic rays is consisting of the muon. There is a cloud of cosmic rays existing in the universe, right? So first you have to take maybe this is the earth, maybe earth sea level you have to consider, sea level of the earth, level of earth. Suppose you have to take the sea level of the earth you have to consider. Once you consider the sea level of the earth, how many kilometers are there from cosmic rays to experimentally you have to take it is a 6 kilometers are there. 6 kilometers. How many kilometers are there? Let you have to take a 6 kilometers. From the cosmic rays, so from the cosmic rays, a muons can transform muon, suppose mu minus, it is decay into the, which one we have to take, one electron it will come, plus one electron antineutrino, plus muon neutrino it will come. This is the decay of the mu minus meson. Mu minus meson decay, it goes to the electron, one electron it will come and one electron antineutrino, one muon neutrino it will give. Clear? So, this is the elementary particle where it is there in the cosmic ray, in the atmosphere this one is there, right. Now, this muon is decaying with velocity to what is that velocity? 0.0098 c velocity, right. 0.0098 c velocity it is coming, right. So, with velocity. So, what is the half life of the mu minus? Half life, you have to consider this half life is 2 into 10 to the power of minus 6 seconds, 2 microseconds if you have to consider, right. So, therefore, how much distance it can decay? So, this how much distance it can decay, the distance is equal to V into time. So, V is equal to 0.998 into C into time is equal to 2 into 10 to the power of minus 6 seconds. So, now you have to calculate this, you will get the 600 meters you are getting. How many meters you are get? 600 meters or 0.6 kilometers you have to get. 600 meters or 0.6 kilometers you have to get. So, how much it will come, this decay in the atmosphere, this mu minus meson, it will come up to the 0.6 kilometers only, this when it will come, clear. So, this is the rest frame if you have to consider. By using a time dilation phenomena, where we have to use this one, once you have to consider by the time dilation, once you have to take rest of the frame and velocity and moving frame you have to consider. Now, you have to take delta tau dash is a proper time. Delta tau dash is the proper time you have to consider, that is the half life of the mu minus meson. Delta tau dash is the proper time. This is half lifetime of the mu minus meson. What is that half lifetime of a mu minus meson? Which is equal to 2 into 10 to the power of minus 6 seconds, 2 microseconds is there, delta tau dash, clear. So, now once you have to know what is the time dilation, delta tau is equal to how much? Delta tau I need to calculate. Delta tau is equal to how we have to calculate? We know the principle, delta tau is equal to gamma into delta tau dash, correct. So, but gamma, you know that delta tau dash is equal to 2 into 10 to the power of minus 6 is divided by square root of 1 minus V square. V is equal to 0.998 is divided by C square, C square, square, C square get cancelled. If you have to calculate delta tau is equal to how much you have to get, 30 microseconds you are getting. How much? 30 microsecond. 30 microsecond delta time. Delta tau is equal to how much you have to get? 30 microseconds you are getting. So, delta tau dash, the proper time is equal to 2 into 10 to the power of minus 6 seconds. Delta tau is equal to 30 microseconds we are getting. So, therefore, based on this, corresponding if you have to take in that frame, you have to calculate how much distance is there, how much distance. So, in the another moving frame you have to take a moving frame. In the moving frame, and the or fast frame, right. So, what is the distance you have to take the distance? So, the distance is equal to d into t. So the d is equal to, already you know what is the d. So d is equal to v into t. So d is equal to v into t. So this v already you know 0.998 c into t is equal to 30 microsecond. Now if you have to substitute 0.998 into 3 into 10 to the power of 8 meter per second into 30 into 10 to the power of minus 6, if you have to see. So therefore how much you have to get? So you are getting that value, how much? 9 kilometers you are getting. 9 kilometers means the distance also is more, correct? The distance also you are getting the more value, how to get the distance also you have to get the more value. So therefore what we have to write? So we are writing this, the distance also you are getting the more, 9 kilometers. From this what we have to conclude? Cosmic rays through muon particles. Therefore we are concluding that cosmic rays through muon particles, we are concluding that cosmic rays, so cosmic rays through mu minus, through mu minus particle, cosmic rays through mu minus particles appears below the sea level, because up to the sea level only 6 kilometers are there, below the sea level. So there is sufficient possibility. So there is therefore what we have to write? So therefore there is a sufficient possibility, there is a sufficient possibility, there is a sufficient possibility of whom? There is a sufficient possibility that some mu minus mesons, reach on the earth surface, some mu mesons reach on the earth surface because of the time dilation phenomena. Clear? So like this we have to apply the time dilation. Now not only this, in mu minus mesons, not only in mu minus mesons, in the cosmic rays there is a 5 plus mesons also is there, 5 mesons also is there. Suppose if you have to take a 5 plus meson takes a time 10 into 10 to the power of minus 8 seconds to cover a distance 30 meters in the laboratory measurement, while a time 1.4 into 10 to the power of minus 8 seconds in their own frame of reference. Thus 7-fold time dilation is existing as occurred in the jet planes. Once you have to going into the moving, so you able to observe how many fold? 7-fold time duration can exhibit, 7-fold time duration can exhibit. That is very, very important one, you have to concentrate. So not only that, one more thing you have to observe. So what is that? Once you have to see, some mismatch is there, but video is properly is coming, but in that app some problem is there, I think some time it is not taking, some red is coming and again it is coming, correct? So once you have to adjust that, otherwise I have to upload this video in that one also we have to see. So that is the procedure I have to do. So once we have to see here. So twin paradox in special relativity, twin paradox in special relativity. What is a twin paradox in special relativity? Once we have to see what is the main objective of the twin paradox in special relativity, we have to see, right? Consider the two twins A and B, each 20 years of age. Consider the two twins A and B, each 20 years of age, tin A remains at rest at the origin O, and tin B takes round trip space voyage to star with velocity v is equal to 0.99 c relative to A. The star is 20 light years away from O. Suppose if you have to take the A, so this A is there. Now this around the A there is a B is there. How much distance is there? For 20 light years distance is there. How much distance is there? 20 light years distance is there from A to B. So B is revolving around its A is in the center and the rest is there, right? Determine the age of A and age of B as B finishes his journey. So B is finishes his journey. After his finishing, so you have to calculate the A and B age. So according to the A, the time taken by B, in the round trip is how we have to calculate. T1 is equal to, which one we have to write? 20 light years means 20 into C years. 20 light years means 20 into C years is divided by how much distance is there? There is a, so how much velocity is there? So 0.99 c. If you have to calculate, you able to get 20.2 years, you able to get 20.2 years. So according to A, the time taken by B round the trip, so how much time is taking? T1 is equal to 20 light years, the distance by velocity. So the distance by velocity we are going to give the which one it is, that is the time. 20 into c into years is divided by 0.99 c. If you have to calculate, you will get the 20.2 years. So therefore, thus according to A, his own age as B completes the journey, what is that? Already 20 years are there, light years distance is the age, 20 years of age is there. So what is that initial age? You have to consider as a, consider the two twins A and B, each 20 years of age. 20 plus, to revolve the B into A, we are getting 20.2, 22 point, so that is the 42.2 years. How many years? 42.2 years you are able to get. That is the age of the A. Now we have to see what is the age. 42.2 years of A age of the A. According to the B, the time of journey, that is the proper time interval, because it is the, so moving in the moving frame is a proper time interval. So that proper time interval is equal to, so T2 is equal to the age 20 years into square root of 1 minus v square by c square 0.99 whole square, which is equal to how much you are getting? 2.8 years we are getting. How much time? 2.8 years we are getting. Clear? 2.8 years. So we are getting this time. So therefore, hence according to B, his own age after the journey is, according to B, his own age after the journey is equal to, so first 20 years are there. According to his own proper time, you have to get it 2.8 years. So therefore, 22.8 years we are getting the B value. So from the age of A is equal to, age of A is equal to 42.2 years. Age of B is equal to, age of B is equal, what is that value? 22.8. These ages are different, so that's why this difference we call it as a paradox. Paradox means there is a flaw. So there is a difference, there is a what we call it as there is a mismatch is there. So these two statements are different. these two statements are different. After the space journey, will one of the two twins look younger than the other? One of the twin looks younger than the B is younger. If it is motion, so what will happen, that age is reduced. So that's why if you corresponding to C, one of the younger will appear to other, because two are the age is same, but even though you have to consider the time dilation principle, you able to get one is younger, another one is the older. So this principle we call it as this is twin paradox. Which paradox it is? Twin paradox, the theory of special relativity. This is very important. This is the twin paradox for the special theory of relativity, in the special theory of relativity. Clear? So how the problems will come in your competitive exam, once you have to see. A clock keeps a correct time with what speed should it move relative to an observer, so that it may seem to lose 4 minutes in 24 hours. 4 minutes in 24 hours. Suppose if you have to consider the proper time. So losing time we call it as that time we call it as time dilation time. So you have to consider. So gaining time you have to consider as which time you have to consider, improper time you have to consider. So therefore the improper time is equal to improper time. Improper time is equal to 24 hours you have to take. Improper time is equal to 24 hours. 1 hour is equal to how many minutes? 60 minutes. 1 hour is equal to 60 minutes. 24 is equal to 60. 1440 minutes you have to take. 1440 minutes. Clear? 24 into 60 is equal to 1440 minutes we are taking. So therefore proper time is equal to less than that time, we call it as a proper time. So 1430 minutes, within 1430 how many minutes it is losing? 4 minutes is losing. 1440 minus 4 is equal to, we have to take this one 1436. 1436 minutes, correct? 1436 minutes you have to consider. This is the proper time. Proper time is equal to 1436 minutes. Improper time is equal to 24 hours we have to consider. Clear? So once you have to take a improper time and proper time, later what we want to calculate? We want to calculate the velocity, how speed, so how the, what is that relative speed they are asking, or velocity they are asking, that speed of that clock we need to calculate. Now once you have to see, improper time is equal to, we know the formula, improper time is equal to gamma into proper time, gamma into proper time. So therefore you substituted that value, improper time is equal to 1440 is equal to 1 by square root of 1 minus v square by c square into speed is equal to, proper time is equal to 1436. So therefore if you have to calculate, so what is that value you have to get it, square root of 1 minus v square by c square is equal to 1436 is divided by 1440. 1436 is divided by 1440. So now you have to take so you have to measure the value. So after measuring this, you make it square on both sides. 1 minus 1436 is divided by 1440 whole square is equal to v square by c square. Therefore v square is equal to 1 minus 1436 is divided by 1440 whole square into c square. Therefore v is equal to, you have to do the square root and simplify, you will get 0.1 c you have to get it. This is your answer. Like this you have to calculate in your competitive examination. It is very important. So how we have to apply, how we have to approach the problem, like this we have to approach the problem. So one more important you have to see, what is the velocity of 5 mesons whose observed mean life is 2.5 into 10 to the power of minus seconds. The proper life of this, proper life means proper lifetime. Proper lifetime is equal to delta tau dash is equal to, what is that? 2.5 into 10 to the power of 2.5 into 10 to the power of minus 8 seconds. Proper time. This is the proper time. Which one you have to consider? It is proper time is equal to. Now the improper time is equal to, also they are giving the improper time is equal to, what is the delta tau is equal to improper time 2.5 into 10 to the power of minus 7 second. What they are asking? Same, they want to calculate the V is equal to how much they are asking. So the same principle you have to use. Improper time is equal to, improper time is equal to gamma into proper time, gamma into proper time, gamma into proper time. Improper time is equal to gamma into proper time. What is the improper time? 2.5 into 10 to the power of minus 7, which is equal to gamma is equal to 1 by square root of 1 minus v square by c square. What is that proper time? 2.5 into 10 to the power of minus 8 seconds. 2.5 into 10 to the power of minus 8 seconds is there. 2.5 get cancelled. 10 to the power of minus 7 minus 1 is there. So therefore the square root of so 1 minus v square by c square is equal to 1 by, so which one we have to write? We have to take so we have to write it is 1 by 10. We have to write it is a 1 by 10. So therefore you have to consider the squaring on both sides. 1 minus v square by c square is equal to 1 by 100. So therefore 1 minus 1 by 100 is equal to v square by c square. This is 100 minus 1 is divided by 100 is equal to v square by c square. 99 by 100, 99 by 100 is equal to v square by c square. So therefore v square is equal to, v square is equal to, what we have to write? The square root of 99 by 100 into c it will come. So therefore v square is equal to square root of, so v is equal to, we have to write it is v is equal to square root of 99 by 100 into, so that one we have to write. So this one how much you have to get it? So you are getting that value. So once you have to see 0.995, 0.995 C you able to get. Like this you have to calculate in your competitive examination. Which one you have to calculate? So you have to calculate in your competitive examination like this. This is the story about the time dilation. Clear? So please adjust. Some black matches is coming sometimes because of that app problem or net problem or computer something is there. It is not dragging this camera to that. So that is the problem. So please practice, otherwise you are unable to perfect in this situation. Clear? So today is enough. Tomorrow we have to discuss one more important application, that is the addition of velocities according to the low range transformations. Clear? Right.